Okay, in this video, we're going to go through the hypothesis testing worksheet by the steps. And we're starting out with means. Okay, so our first example. In a recent medical study, 76 subjects were placed on a low-fat diet, and then a bunch of stats. Can we conclude the mean weight loss is greater than 0? So this is our main question. It's a question about the mean. And this question, the can we conclude question, is what we are trying to show. So this is going to be our alternative hypothesis. So the first step, this is what we went over last time, is just to practice. Okay, that's my cuckoo clock. Just to practice going over step 1. So we're going to start with step 1. State the null and alternative hypothesis in the context of the problem. So that can you conclude question, that's our alternative hypothesis. Can we include the mean is greater than 0? So to put that in math, it looks like this. The opposite of that is that the mean is less than or equal to 0. So that is our null and alternative hypothesis. Okay, step 2 says identify the significance level. Well, this is something that's always given to us. We just have to go back to the problem and find it. So it says we're going to use alpha equal to 0.05. That's our significance level. We want to find the critical value or values. So the next thing we need to decide, is this a right-tailed test, a left-tailed test, or a two-tailed test? And we're going to go back up to the alternative hypothesis and think about the alligator. So this is a right-tailed test. So we have one critical value on the right-hand side. And so we want the area in this one tail to be equal to 0.05. That's our alpha. And this area over here is 0.95. The other question we need to ask, is this a Z distribution or a T distribution? We have a mean and we have a standard deviation, but that standard deviation is the sample standard deviation, right? We have S, the sample standard deviation. So this is a T distribution. And we've got N equal to 76. So our degrees of freedom is 1 minus that, which is 75. And then we're going to look this up on a chart to see what our critical value is going to be. And I have a chart. Sorry, excuse me. All right, so 75 degrees of freedom isn't on my chart. We're going to round that, well, let's round it to 80. And area in the right tail of 0.05. We have a critical value of 1.664. So we'll go with that. Is everything okay? All right. So step 3, we're going to verify that the assumptions are met. For a mean, we have 2 assumptions. We need a good random sample or a good randomized experiment. And we need N greater than or equal to 30 or a population that's normal. Okay, so N in this case is 76, which is greater than or equal to 30. So that one's easy. That one's good. Do we have a good randomized experiment? It says it's a recent medical study. 76 subjects were placed on a low-fat diet. We're not really sure here whether that's a good randomized experiment or not. So we're going to assume that it is and come back to this at the end of the problem. In step 4, we're actually going to compute the value of the test statistic. So this is where we put things in the calculator. The calculator function is called t-test. And we get there from stat and then test. And you'll see it on the list. And then it's going to ask for several things. The first thing it's going to ask for is mu sub 0, which on a TI looks like a mu in a box. This is the value of mu in the null hypothesis. That's what that stands for. So our null hypothesis is that mu is equal to, less than or equal to 0. So this value here is going to be 0. It asks for n, which is 76. It asks for x bar, which was given in the problem as 2.2 kilograms. It asks for S, our sample standard deviation, which is 6.1 kilograms. And then it also wants the alternative hypothesis. So we need to enter the alternative hypothesis. I know it's the alternative hypothesis because none of my choices have equal in them. And I think we need to pause the video. Okay, so I forgot to bring a TI calculator home with me, so this is my Casio. So again, if you're on a TI, you're going to go to stats and test and t-test. It's right there where the intervals are. On my Casio, I hit test and t and one sample. And I want to input variable. On a TI, it's going to say input is stat. And here is where I pick my alternative hypothesis. And again, my choices on the Casio are just like they are on a TI. None of these have equal in them. So I need to match this up exactly to the alternative hypothesis, which is greater than 0. So I'm going to pick greater than. Mu sub 0 is 0. X bar is 2.2. X is 6.1. N is 76. And there's my output, which will look very similar to the output on a TI. Notice the very first line is that mu is greater than 0. That first line needs to match our alternative hypothesis. It needs to match what's in the question, which is that the mean is greater than 0. Then we've got a t value. I'm going to write that down. 3.144. I'm also going to write down that next number underneath, p, and we'll come back to this in a little bit. This is 1.19 times 10 to the negative 3. So this is my output. Again, I want to check that first line, make sure it matches the alternative, but this is what I'm looking for. I'm looking for that t value. And again, we'll come back to the p-value in a little bit. So what is this saying? What is this t-value telling me? Well, it says this value, this x bar of 2.2 is 3.144 standard deviations away from the mean. Let me see if this color works. So here's my mean. Right, and my value, that 2.2, that pen's not really going to work. Oh, that was a nice thought. All right, we'll use a great big old Sharpie. So there's my mean. My 2.2 is 3.144 standard deviations above the mean. This value. So anything bigger than my critical value, I'm going to reject. Anything on this side, these are the things that are likely to happen if the null hypothesis is true. Anything over here is unlikely to happen if the null hypothesis is true. So 2.2 is unlikely. If the mean really is 0, then to get a sample mean of 2.2 is strange. It's unlikely. And this gives us evidence against our null hypothesis. Right? If the null hypothesis is right and the mean really is 0 or less than 0, then we've gotten this really strange result. So now we can move on to step 5. Step 5, we decide whether or not to reject the null hypothesis. We are going to compare the test statistic, that was our 3.144, to the critical value, which was 1.664, and the critical region that we found in step 2. Right? If the test statistic is in the critical region, the rejection region, then we're going to reject the null hypothesis. And that's what we saw. We're going to reject the null hypothesis. We found some evidence against it. The p-value method, let me explain what the p-value is. The p-value is the probability of finding a value more extreme than our sample value. So it's the probability of this area right here. Probability of a value more extreme than x bar. So our p-value was 1.19 times 10 to the negative 3. Right? If we want to write that as a decimal, it looks like this. And this is very unusual. Right? We set alpha to be 0.05. So anything less than 5% would be unusual. This is less than 5%. And again, it's the area of the curve on the extreme side. Anything more extreme than x bar. So another way to see if we can reject or not is to look at the p-value. The p-value we're always going to compare to alpha. And if the p-value is less than alpha, we reject. Therefore, both of these methods tell us that we're going to reject the null hypothesis. Step 6. We're going to state the conclusion in plain English. Plain English means I'm going to avoid words like hypothesis and null hypothesis and anything that just sounds like statistical gobbledygook. So the best thing to do is go back to the original question. Can we conclude the mean weight loss is greater than 0? Well, we rejected the null hypothesis, right? So if we reject the null hypothesis, this is our conclusion, and this is what I need to write in English. Can we conclude the mean weight loss is greater than 0? Yes. We can conclude the mean weight loss is greater than 0. And that's our conclusion. But now there's one more step. We want to evaluate any limitations that might be present. For this, we're going to look back on step 3 and think about any questions that we had. We weren't entirely sure how they picked these 76 subjects, right? So this conclusion will only hold if they actually did that correctly. The conclusion holds only if this is a good random experiment. All right, let's take another break.